Thanks for having me. Really excited to talk about fake data and how Tonic and Hasura play so nicely together. So this is a data set that we actually use in Tonic sales demos. It's already fake data. Obviously, for the point of our demos, we assume it is real data and then show how Tonic can properly de-identify that data set. The data set itself is from a retail location. It includes information on customers, employees, and transactions and products as well.
So this is real fake data.
Now again, we're pretending it's real for the purposes of our demo, but obviously when we demo to customers, we're not showing them anyone's real data. I mean, you have to be very thoughtful when you release public data, not only about what's contained in the data itself, but what can be gleaned by then joining that data with other public data sets. It can get it's a very complex
which brings
problem.
us back to Hasura.
Great, there you go. Oh, yes,
connecting multiple data sets.
Yeah. Perfect. They can use Hasura. That's awesome.
Well, hello everyone, and welcome back to another data and API show where we are focusing on the data side of things. This has been a whole series on databases, all kinds of databases, machine learning and databases, Postgres, BigQuery. We're going after all of it that we can. And there is a small subset in that space that often gets overlooked by teams until it is too late, or they're trying to go for their SOC 1, SOC 2 compliance, when that is about how do you work with your customer data in development? Because apparently, as I have heard, shipping customer credit cards and things like that to development machines is generally frowned upon in today's environment. But for that, we actually have a special guest today, Adam Kamor from the company Tonic. How's it going?
It's going great. Thanks for having me. Really excited to talk about fake data and how Tonic and Hasura play so nicely together.
I have one question before we actually talk about serious stuff. Was there just like unbearable amounts of puns with fake news to then fake data? Like,
yeah, I actually don't know what term came about first. I'm not sure who was first there. I'm gonna say we were, even though that might not be true.
Yeah, well, that might be fake news, but we're gonna go for it because apparently that's what you can do if it's on camera. Yeah, so if it's recorded, it's got to be true. But anyways, thank you so much for joining us today. Why don't you give us kind of a quick rundown about who you are, maybe a little bit of your background, and how you sort of came into the fake data business, and what is it we're actually referring to about fake data itself?
Sure. So my name's Adam. I'm the head of engineering and also one of Tonic's co-founders. Tonic was co-founded back in 2018, so I think right around the time you guys actually started up, if that's correct.
Yeah, right about there.
We got into this space because we think it's an important problem to solve, and it's meaningful, and it helps people, and especially our customers. And B, it was a problem that myself and my co-founders, I believe, were uniquely situated to solve. Just our previous experiences, our past jobs, and what we did in those jobs, I think made it obvious to us at least that we should be working in the data space. And the problem of fake data, or rather the problem of not having fake data when you need it, is an experience that all of us had faced, in our careers up until that point. Needing de-identified data and just not having it available to us, and having to go create it yourself, and going through that pain is something that we'd experienced. Like, I think actually a lot of developers have experienced, and that's what kind of motivated us to get started.
Yeah, because I think it goes beyond even, and this is, I think, getting to the unique part that you're trying to solve at Tonic too. It's also much beyond the just having de-anonymized data, or having fake data that represents the schema somewhat, because you need to have representative data. It needs to actually somewhat replicate or resemble what it is you're working with. I can think of Facebook with their design team. Similar problem set was, they had these designers creating beautiful UIs with just very attractive people with really well written, personal bios, the right length and everything. And they actually created a tool that would pull random users, like real users, into the dev environment to actually be like, this is somebody's up nose shot, and this is their like 30 paragraph bio. You got to make that work in the design. So yeah,
that's right. That's right. With their bio with like unnecessary emoji use. Yeah. No, I get that. There is it is definitely not true that fake data equals garbage data. In fact, like we wouldn't be around if the data that we generate was complete nonsense. And like it's kind of like there's a bare minimum that you need when you're generating fake data. There's really two. It needs to be not re-identifiable back to individuals. Like that's obvious. Otherwise, it's not really fake, right? And two, it needs to be of sufficient quality so that when you like connect your actual application to this new de-identified database, the application's still going to work. So like the schema and the data types and the foreign keys and the indexes, that all obviously has to be there. But the data itself then needs to adhere to whatever like the business constraints are of the application. Like if the value in this column is this, then the value in this other column must be this, or this. It can't be that. Right. Like adhering to all of those constraints, which really kind of like embed your application's, logic, the business logic that your developers have coded, to generate that is non-trivial. And we call it fake data, but it's actually really high quality fake data.
Yeah, because I think the whole promise of Hasura, GraphQL, and our half of the ecosystem is that there is this tight contract between your database schema and your whatever the consuming client is going to be. The
That's right.
GraphQL ensures the data is going to be the way that it's described, and you have these objects like we talked about in the last show, these typed objects that act as this contract between the two. And
Hmm.
you're going to be working with a production database, you actually need that contract to remain true. You need the assumptions about your data, the shapes of your data, the relationships of your data to be consistent. And then also the content in there, again, needs to adhere to, well, if you have a subset of union types that need, or of this shape or whatever, those all need to actually
That's
exist.
right. That's right. Like,
Yeah.
sometimes we get lucky. Sometimes like the complexity is all enshrined in the foreign key constraints that are in the database. And that's easy. We can programmatically read those and understand them. But other times there's these constraints that aren't represented via foreign keys and they just exist in the application code. They're assumptions the application makes about the database. And those can be tricky to, properly de-identify, but it's a problem that, Tonic has solved.
Yeah. I mean, that sounds like it's exactly like why Tonic exists. So,
Yeah, I
um,
I, I agree with that.
what was the? Can you give us one example of a worst case? Like you came in and somebody was doing like trying to de-anonymize any references. Do you have an example of a
Yeah,
case
I
where
mean,
Tonic saved the day?
yeah, I mean, it is. There's the schemas that customers have can vary widely in complexity, right? There's customers where it's a single table, and then there's customers where there's, I mean, no joke. I think the largest schema database that we've come across is 40,000 tables in the schema, and that was for a product that allowed customers to like generate their own forms. And the basically each like the forms that were generated were represented in these tables that were like programmatically created. So it was just a tremendous number of tables, and it was very very unwieldy. And we actually the way our product works and the way that we can kind of like make bulk transformations on many columns and tables at once, and the way that we can allow users to kind of like in the UI tell us about various constraints that need to be satisfied, kind of like made it a much more tractable problem in the end. And I think that was a good one. Yeah, it was. In fact, though, I mean, not to say that we nail it every time. I think when we were kind of onboarding that customer, um, initially the UI wouldn't even load. Right? It was we weren't expecting to see our responses from our server that were so large. And so verbose, given that there's like 40,000 things it's trying to talk about all at once. So there was definitely a lot of pagination work we had to do initially. But once that was done, I'd say it went pretty smoothly.
Well, being in the space of generated GraphQL schemas and having been in that space for a while, I can say that I appreciate very large responses from the server.
Yeah, yeah, it's something. But I'm now that we've done that though, we can basically, I think, handle most schemas. So I'm glad that happened to us, I guess, because now we don't have to
Yeah,
worry about it so much.
yeah, that is the beauty of the startup space is you have a customer that needs that bespoke tool that's going to solve their problem, and it pushes and it stretches the shape of what you're able to solve, that your solution set, it shapes that
That's
in a
right.
way that you can now handle everything from there to your initial core
That's
idea.
right. But then there's then there's those bespoke things you do that you're convinced everyone's gonna want, and you spend a long time on it, and then it's like, oh, okay, no, it was actually a little too bespoke. So the coin can flip both ways.
I'm in the middle of reading The Mom Test, which is a book
Yeah.
all about asking the right kind of questions for introspecting with customers, and he
Yes.
has a lot
So
of those kind of use cases. Yeah.
when we first started Tonic, I met with someone who gave me advice to go buy that book and read it. It came highly recommended.
Yeah, it's very good. And I would even add an extra plug for the Audible version, because when I say I'm reading it, I mean I'm listening to it, because I'm one of those people that are killing books
Yeah.
apparently, because I'm millennial.
Okay. Uh huh. Uh huh.
But it's read by the author, and he really adds a very personal tone. Like the way he's actually reading what he's written. There's a lot
Okay.
of additional layering of stressing this. He doesn't read it like the typical audible read back from an author. He's like, there's sarcasm laden in this area. There's
Okay. Oh, that's
stresses in this
interesting.
area. So it's
I,
kind of fun. Yeah.
I can't listen to audiobooks. I don't get anything from them, unfortunately. You can see some of my bookshelves behind me though. So I
Yeah.
I I still purchase books. I should probably give it another effort. I feel like whenever I would listen to them, I would I don't know, I couldn't take it in as much.
The
But
single
maybe it's
piece,
different
the
now.
single piece you got to use is the clip functionality. So if you're
What is
playing
that?
back the audio, there's a button on the bottom corner that says clip, and then you're able to actually add a note to that part of the audio
Oh,
track. And then
fun.
later on, you actually can see your notes, and then
Yeah.
like a 30-second snapshot of the book at that
Yeah.
part. So you can kind of say, oh, that's the part I want to go back and review later or whatever. So it's kind of like
Sure.
marginalia, but in audio
Yeah,
form.
it's like in your college textbooks, you'll have like 1,000 post-it notes sticking out from various pages. It seems
Exactly.
like it's kind of like that.
It's exactly like that.
Cool. Oh, that's nice. I like
Yeah,
that.
that sounds. So moving back to fake data from Audible, um, the so we're going to have a look at kind of how this tooling works. You said that you had sort of your background gave you a unique perspective. What was part of your background, and what made this problem so challenging to actually tackle, that like it needed a company behind it? So kind of what was your background, and how has that then been applied to making this
Got it.
unique to
Got it.
solve this problem? Yeah.
Sure. So I guess I'll give a little. I'll share a little more about myself. I graduated with a PhD in physics from Georgia Tech back in 2013. So that's coming up on 9 years ago. And then from there, I went to work at Microsoft. Well, I moved to Seattle from Atlanta. Went to go work at Microsoft, and then from there, I went to Tableau, which is another Seattle-based company. They do, data analytics, data visualization, and that was kind of my first foray into the data space. At Microsoft, I was on the Windows team, and which eventually was the Windows Store team. So, great product, great team to work on, but not super data heavy. So when I'm at Tableau, we would occasionally, customers would respond with, "Hey, I think there's an error in my Tableau workbook," and I'd be like, "Okay, well, send it to us," and they'd send us the workbook, and then we'd be like, "Okay, well, we need to be able to connect to your database," and they'd be like, "No," right? Because that's like that's crazy, right? I mean, why would they give us that access? So it's just like the need for fake data like became very apparent then. And then from there, I worked at another software company. This is now I've actually moved to Atlanta at this point because my wife and I had our first kid, and we wanted to be near family again. So I'm in Atlanta now, and I was working at an Atlanta company where it's a fintech company. Atlanta is pretty big for fintech, and the need for de-identified data in testing and development was just it's very obvious, right? And it just became more and more clear like this is a problem that developers are facing. That was actually my first development job. I had done a little bit of development at Tableau, but I was primarily actually a product manager at Tableau and Microsoft. So this is my first kind of time being a software engineer, and it just became like immediately obvious to me this is a problem. Developers spend a lot of time like combing the staging database for um, users and situations that they need to test against, and it was just really really painful. So around this time, my co-founders had reached out. We decided we wanted to start a company, and this was one idea among many that we had. Most of the ideas were terrible. Just crazy ideas. Like, why, like looking back on it, I don't know why we thought we would try to solve that, and that it was even worth solving, frankly. But this problem, I don't know who brought it up initially, but whoever brought it up among us, everyone else was like, "Oh yeah, I've had that problem before," and it just became really obvious. Like my co-founder Ian has a very similar story from working at Palantir, where it's like he's working with customers, he needs data to replicate issues, and you just don't have it. Um, given our the team itself, the co-founding team is very technical. I think everyone on the team is originally an engineer. Myself and the other technical co-founder Andrew, we both have PhDs. Him in computer science, me in physics, and my physics was more on like the um, computational and mathematical side of the house, not experimental. So like we've always been like numbers guys and into math, I would say, and this is a problem that really involves a lot of that. Um, I think is the second thing that you asked me. It was not about my background, but it was more about like why is this a hard problem to solve, and
Yeah, how
why
does
build a
that
company around it.
map? How does that
Yeah.
project
Okay.
from your skill, from your experience, then
Sure.
to solving this problem? What's challenging about
Got it.
de-ident? Because I also want to highlight, because you've said it a couple of times, and I've kept throwing it back to fake data. I think very much, I guess, in the case of your case in specific, and we're talking about like Palantir, so there's reasons why those customers would not want to give access to the database. De-anonymized is actually the key word there, right? Because it is something where it's actually much more representative by nature of the original data set when it's de-anonymized versus
Yes.
truly generating
So
like a similar phone number.
when you say de-anonymized, you mean anonymized, right? De-anonymized would be reversing the anonymization.
Anonymized, correct? Because
Anonymized.
de-anonymized is not what you wanted. That's what the black
It's the
hats
opposite,
do.
in
Yeah,
fact.
that's
So the term that I use most often when I'm not using the term fake data is de-identified data.
de-identified.
Uh,
That's the term. I was mixing them.
yeah, I
De-identified.
think
Yeah.
right, exactly.
Yeah.
So
Yeah.
yes, de-identified data is very different than data from scratch. Like data from scratch, here's the schema I want. Fill the schema with values that match the schema. Like if it's an integer column, random integers. If it's a string column, random strings of the appropriate length. If it's dates, random dates, etc. Right? That almost never works. And I'll talk about that in a moment. But let me share with you why it's hard to actually generate de-identified data and why a company exists around it. And then I can go back to um, de-identified versus from scratch data because there's really a key difference there. So this is a hard problem to solve, and any developer that's tried to do this in their own projects or at a company they're working at will understand this. I think when you go to generate de-identified data or data from scratch, you need to generate data that the application is going to understand and be able to work with. And it goes back to those the constraints that are kind of in the application code, the assumptions the application code makes that aren't in the database. In any reasonable application, there's going to be hundreds, thousands, tens of thousands of these assumptions being made in the code. Like, okay, the data in this column is this other value, therefore will be this or that. Otherwise, throw an exception, right? So, a developer that goes to build their own, fake data set for like application testing, okay, day one comes around, they go to the users table. It's like, oh, this is easy. A name column, here's some names. A salary column, here's some numbers. Great. Then you get to day two, and it's like, okay, well, there's this table that references customers. Okay, so let me go create a bunch of foreign keys in this table that point to valid customer IDs, right? And then, okay, well, there's actually 30 tables that all reference customers. And then of those 30 tables, 20 of them are referencing each other. And then they're referencing these and that. And all of a sudden, you very quickly realize it's actually like a super intractable problem. It is like really, really hard to generate this de-identified data that's sufficiently of high quality for the application to work on an application database of any like reasonable size. Like once you get past a few tables, you're in trouble. It gets really, really nasty. Um, but then it's like, okay, well, let's just fill every table with purely fake data from scratch, which is I think what you were just talking about. Well, yeah, you can do that, right? Like I can write code that will look at a table, will look at the data types of the columns, and then generate garbage that'll fill it in. But that's not useful for anything. I mean, you can't test an application with that data. The application most likely won't even load up. Which is why you need that de-identified data where like a de-identified data, every row in the source database, you're actually analyzing it, de-identifying it, and writing it to the output. It's like a one-to-one mapping between source row and output row. Whereas with fake data, I mean, you don't have that, and fake data is easier to generate, but the utility of that data is very low for most use cases.
Yeah, because you can still draw meaningful, like real, like you can actually have de-identified data be part of your BI set. Like
100% you
you
can.
may give your analysts, like, so that it's not just about development content. It's also about saying, well, this is actually just the content that you want to have for like what we're exposing. Like in the case of Hasura, you could literally have two tables in parallel. One table is prefix de-identified, and one table is the original. And you can then control and make permissions and say, for these set of users, they have access to the de-identified tables, and for this set of users, they don't have access to those
Yes.
tables or whatever.
Yes, you can.
That's a totally different business solution. Because I mean, the problem you're talking about with the trying to create 30 tables with matching, I've used your guys' free tool, the Mockeroo, to try to
Oh,
recreate that.
Mockeroo is not our tool. It is a it
Or
is
you sponsored or what?
it's not even sponsored. We've had partnerships with them in the past, as well as joint webinars. It's we know the founder of Mockeroo very well, Mark. Great guy,
Okay.
and Mockeroo is a great tool.
Yeah.
Um, the way that we kind of position Mockeroo and Tonic is Tonic takes an application database and will spit out a de-identified database. Mockeroo is more appropriate for when you don't have any data, but you know like what schema you have, and you want to generate fake data for that schema,
Well,
and
the
that's more
viewers of
fake
this
data from
show have
scratch.
seen Mockeroo in action a number of
Yeah.
times.
Oh, Mockeroo is a great tool. Mark is
Yeah.
great guy, very successful with Mockeroo, and just really sharp. Yeah, I can't
That's
say enough
awesome.
great things about Mockeroo.
That's really cool. Yeah, no, we've I use it heavily for because I'm DevRel, so I don't have real data. You know, there's
Yes,
nobody creating
exactly.
pizza
Yeah, that's a
shops
great
made out of
Mockeroo
emojis.
use case.
Like, yeah. So, yeah, that's really cool. Yeah, the de-identified. So this is really a very substantial use case because again, like it is actually a product in of itself to create this sort of data because you may want to find out how do you solve like geo data when it comes to de-identified. What's because that I can imagine
Lots of
be
different
really
ways.
different. Yeah.
It can be. We have various data transformations for geographical data. Like, you know, the simplest case is, okay, you just want random cities and states, and of course, every city needs to be generated in the appropriate state. Okay, sure. Then you might have like a zip code column added on. So now we'll generate a random city state zip triplet. Okay. But other times customers want to take, and that would be if like you are fine with random locations.
Mhm.
But excuse me, some customers actually want to like you said, de-identify their geographical data as opposed to just make random values from it, right? So if you want to de-identify it, the options that we have, I mean, there's let me think. There's one where given lat longs, given a column of lat longs, we will actually de-identify the lat longs in a way where we noise them, but the amount we noise each position by is going to be a function of how many other positions are close to it. So if you have a bunch of, you know, if you have a cluster of points all within a city, we don't have to shift those points very much. Because once you if you have a cluster of points, if you shift each of them by a little amount, you actually don't know what point was originally what other point, right? Because it's all
Yeah.
kind of just gets mixed together. But then if you got one point out in the desert, well, that's a problem. You got to shift that bad boy by a lot to have some plausible deniability there as to what it is, right? So like it can get very complex in that way, and in the way we do that.
Well,
So
this
you know
was
everything from
Strava's
random
problem,
cities
right?
to that other. What's that?
This was Strava's problem, right? Because they had the interactive heat map a while back where they had broadcast you, you if you did not turn it off, I think it was on by default, location
What is
sharing.
Strava actually?
Okay,
I'm lost.
Strava is one of the original location tracking for sports, biking, whatever else, and they would do
Oh, okay,
a lot of tracks and segments of your path. So, anyways, or Strava, I don't know how you pronounce it, but
okay.
anyways, they were very popular, are very popular. But they had a case where for one Christmas they decided, hey, we're going to go ahead and make this big, beautiful map from all the public data we have. You can go on there and you can see all these paths from everybody's public data that they had made public. Well, apparently some of the U.S. servicemen, which we support you, they did not turn off their public data toggles, and we had very crisp outlines, like in the outskirts of Baghdad and things, of like
Oh wow.
the U.S. military bases and things like that that were
Yeah, that's
quickly
something.
taken down.
Yeah, that's I
But
mean, you have to be very thoughtful when you release public data. Not only about what's contained in the data itself, but what can be gleaned by then joining that data with other public data sets. It can get yeah, it's a very
which
complex
brings
problem.
us back to Hasura.
Great. There you go. Oh yes, the
Connecting
joining of
multiple
data
data
sets.
sets. Yeah.
Perfect. They can use Hasura. That's awesome.
Let's actually show people what we mean by this, because I think this is a really fascinating use case, and because knowing the tolerances for fuzzed data or for de-identified data is such a tricky problem state. Because I've done a lot of research in the healthcare space, and especially in healthcare, it's like, well, it may be meaningful that like all of these cases of whatever sickness actually follow this water pipeline, right? So
Right.
de-identifying this data that you want to make available to researchers, but at the same time you want to keep every possible bit of semantic value here to say this is something that might be significant, we don't know yet, and knowing what tolerances you have there becomes something really really challenging,
That's
especially
right.
in the healthcare space. Um, but what we're going to do here, we're going to pull up a demo. I have one of your databases hooked up to Hasura, and we're just going to have a quick look at what it sort of looks like. And then we're
Great.
going to just show really how quickly it actually de-identifies. So I'm going to share my screen here. And yep, there we go. So basically, we have a database connected to Hasura. This is not groundbreaking information for any of the viewers to this show. But yeah, we've got customers, customer data. Talk me through a little bit what the data set is here we're looking at.
So this is a data set that we actually use in Tonic sales demos. It's already fake data. Obviously, for the point of our demos, we assume it is real data and then show how Tonic can properly de-identify that data set. The data set itself is from a retail location. It includes information on customers, employees, and transactions and products as well.
So this is real fake data.
Yeah. Now, again, we're pretending it's real for the purposes of our
Yeah.
demo, but
Yeah, yeah.
obviously, when we demo to customers, we're not showing them anyone's real data. That would be, madness.
More or less. So so if we were to go ahead and query, I'm going to go ahead and just do a query here on some sales. I think was what we had kind of been talking about earlier. So I'm going to limit this to like a top 10, and then we can kind of look at that data. Will it de-identify positionally in the database? So like, will the first 5 rows essentially be de-identified and to a similar value? So the first 5 will still be the de-identified version of the top 5 from the output.
Yes. Essentially, you can optionally de-identify primary keyed values. That is sometimes necessary when they contain sensitive information. But I think for what I'm going to do today, I'm not going to de-identify any primary key values. So yeah, they should all kind of match up.
We got retail sales here. What's going to be some data here that's kind of interesting? So we have the date
So
key.
I would
Is that one that's going to be
no,
de-identified, or
we're not going to de-identify that. I'm going to call an audible, and I apologize for this. I think we need to query the customers table because that's where I'm going to focus mostly on the de-identification for today.
sure? Okay.
And I'll tell you some fun columns to look at. I would look at let's do first name, gender, marital status, and occupation.
Almost the entire tax payload.
There you go.
So, all right. So I'm going to go ahead and limit this, but to the top 5 here. Got this weird. There we go. Limit. I'm going to limit to the top 50 just so we have something to look at, and then I'm going to go ahead and actually order this by, we'll say the
Customer key would be
or
fine.
customer
If
key.
you wanted to compare the source and the output when we're done.
Sure. So we're
And
gonna
it's a small sample.
this is gonna be our output set here. So we got Sarah, who is female, widowed, and a psychologist. Teresa, Kimberly, Ashley. So we got cobbler. That's quite the
Like I said, it's not a real data set. There's a tremendous number of cobblers as occupations in this
there.
data set. That's
Yeah,
a
there's
downside.
and priest, banker. We got rabbi. This is a very representative of
Yeah,
the U.S.
100%.
So yeah, very
Acrobat.
good.
You just passed Acrobat and Butler. I think those are actually the best.
Yeah, that's. I'd be curious to know marital status by occupation, what the breakdown is there. There might be a
Yeah,
correlation
you
in this
could
data set. No.
if you wanted to run some analytical queries afterwards on the source and the output. For example, if you wanted to know what's the probability of being widowed, given that you're a male or a female, or there's an income column on this table. If you wanted to look at the average income by occupation, Tonic will ensure that those values look reasonable in the source and the output.
Let's try and make that actually. Let's just go ahead and add that to the result here, so we can kind of have something to look at. So we have this query. It's going to be part of my history now in case I have to pull it up again. But I'm going to go ahead and
Cool.
copy to my clipboard. But basically, this is vanilla. We have a Postgres database connected. We track the tables inside of Hasura. And what we're going to do now is you're going to generate the fake data, which technically does drop the tables. So what we're going to see is if the Hasura metadata, which is actually backing all of this, if it actually is smart enough to keep the table tracking, or if it's going to be something that maybe we actually have to retrack. We're actually not sure about that. That's the live
Yeah.
part of this query.
Yeah.
So at this point, I'm going to stop sharing my screen and you're going to share yours and we're going to see what it looks like.
Awesome.
So let me go ahead and take mine off screen here.
Cool. And how long would you like me to spend on this demo? Because I can go short or long.
We've got 20, 30 minutes.
All right, I'll try to keep it at 15, 20, and then we can, maybe chat a bit at the end and show more of Hasura.
Yeah, let's do it.
Screen. Excellent. Are you able to see Tonic right now?
I believe so. Yeah, it looks like a Tonic interface.
It looks like a Tonic, and you see my mouse moving.
Yep.
Awesome. Okay. All right. So I've already connected to a database for today's demo, and it's the database that actually we were just querying in Hasura. Let me show you what it looks like to connect to a database in Tonic. Right now, I'm connected to a Postgres database. And here, this is basically the UI that one would see when connecting to any, database in a SQL client. You need to provide the information that forms the connection string. The only real difference with Tonic is that in addition to providing a source database, you need to provide a destination database. This is where Tonic is going to put your de-identified output dataset. So I think what you were just showing was actually this database that you are connected to. And once we run our demo, we're actually going to query it again and see the de-identified data land in there. In addition to supporting Postgres, we actually support tons of other databases. When I create a new workspace, I can select from this list of databases. So we have many application databases, all of the key ones, I think. And that includes SQL and NoSQL databases. Here's Mongo, for example. We support various data warehouses like BigQuery, Redshift, and Snowflake. And we support the operating on flat files via Spark. You can either use Spark on Amazon EMR, or you can bring your own self-managed or self-hosted Spark, or you can use Databricks. And we support Databricks right now in both AWS and Azure. Excellent. Okay, so I've connected to this database. The first thing that I do when I connect to a database is run the sensitivity scan, or said another way, actually, Tonic will automatically run a sensitivity scan. This is going to look at your database and find the sensitive columns, those that contain, information about customers that we don't want anyone to see. This is a really crucial step for most of our customers because they typically come to us with very, very large databases with hundreds or thousands of tables and thousands or tens of thousands of columns. No one in the org really knows where all of that sensitive data is. So having a tool that will kind of tell you where it is as a way to bootstrap yourself is really, really valuable. We can see some of the results of the sensitivity scan here. For example, 27 columns are considered sensitive, and you get a breakdown of these columns by table in this view here. Each of these rectangles represents a column in a table. This is the customers table that we were just looking at in Hasura. The rectangles that are in red are sensitive. That makes sense, right? Name, gender, email, etc. And the columns over here are considered not sensitive. Again, that roughly makes sense. We could argue, for example, though, that marital status, hey, that actually might be sensitive. If you're not sure whether or not that's sensitive, we can actually go ask. So the security alias is already a member of this workspace. They can work with it and comment on it. Is this sensitive? So I can pose them a question. They'll get an email notification about having received a question, and they'll eventually respond. Let's say they've actually already responded, and they've said, "Hey, yeah, actually that is sensitive. Our bad." I could actually just go here and tell Tonic to begin flagging this column as sensitive, and just like that, you're done. Here's first name that was properly flagged as sensitive. You can actually see what the data looks like from the database. This is straight from the source. Yeah, those are definitely first names. Let's go back here and actually apply a generator, which is going to safely de-identify that column. And now the column's in blue, so it's nice and safe. So really, our goal when using Tonic is to get rid of all the red squares. Either acknowledge that, hey, no, they're not actually sensitive, or apply a transformation so that they're properly de-identified. Everything that I'm doing in the product today, by the way, you can actually look in our audit trail to see a history of all of the changes that have been made. So you'll know who made what change and when they made it. And additionally, everything that I'm going to do today in our UI can programmatically be done via our REST API as well. And you can just go here, get straight to the API documentation. This will bring you to a Swagger doc, and everything that I'm going to do, every click I make, you can do programmatically as well. All right, let's go a level deeper into the database. This is our database view. This is where you can see all of the tables in your database and all of the columns. So you can see there's only like 10 or 12 tables in this database. That's because this is just like a sample toy database that we use for demos. This is not representative of like the normal complexity our customers bring us with their databases. But this view that we're in right now is really purpose built for applying transformations on many, many columns at once so that you can quickly get through a database. So you don't have to spend too much time, using the tool. We've already applied this name generator on first name. You can see here's the original data. Here's the de-identified data. Now this data, these names are drawn at random. So there's not a lot of data utility here, right? Like it's good to get fake names. It's safe, but we're not like looking at the original names to determine what fake names to use. And you can see that here, right? Like Melissa appears twice on the left in the original, and it's getting de-identified as Murdy and Gary on the right. Those are two different names. You might actually want that. It's much safer to always choose random names, but then again, the utility of the data is less. And you'll see this theme throughout the demo. You're always making trade-offs between the utility of the data and the privacy of the data. And as you make the privacy more, the utility is typically less, and the opposite is true. As the utility goes up, the privacy will go down. So we have to make those trade-offs, and Tonic is the tool that lets you do that easily. So if I want to ensure that Melissa always gets the same de-identified output name, I can actually go here and enable consistency. When I do that, I'm guaranteeing that Melissa will always get mapped to Rosella. And I can guarantee that consistency within a column, within multiple columns in the same table, within columns in different tables, and even in columns across databases. So if you have an application database in Postgres, and if you have a data warehouse in BigQuery, we will guarantee consistent mappings of your data when consistency is enabled. So this is really important, for example, for preserving those like natural keys that might exist in the data set that aren't really enshrined as foreign keys. By the way, as I'm going through this, Jesse, if you have any questions, feel free to chime in. Happy to talk.
Yeah, sure.
Great. So real quick now, okay, I see there's like names all over the place. So if I type in name, yeah, there's a lot of columns that have name, right? So let's actually just filter down the first names. Let's do what I just did on one column. Let's do it to all of the columns at once. Just because, we don't want to be, using our mouse and clicking all day. So just like that, all of my first name columns now have this consistent name generator on them. If I get rid of this search, goes back here. We're going to now go a level deeper in the database. Like there's a lot of red columns here, right? Like we got to get rid of them. The red ones are the sensitive ones. In fact, if I wanted to, I could go here and I could actually, how do I do this? Oh, right there. If I click on that view, I actually get a bunch of filters here. This actually gives me all of the sensitive columns that are not yet protected. So first name's not on here because it is protected, right? But every other column is. So I can really think of this as my to-do list. As I add transformations to these columns to de-identify them, they'll be removed from the list. And when the list is empty, I'm good to go, and I can click generate data and actually, get my output database. But like I said, let's now go a level deeper. So now I'm actually looking at a table of data. This column's yellow because I've already applied a name transformation to it. All the columns with red headers are still sensitive. So I got to do something about all these guys, right? Well, for last name, one option I have is actually to use name, make it last, make it consistent or not. But then I get to gender. I don't have a gender generator, but what I do have is a categorical generator, which Tonic is suggesting we use. Categorical generators are great when you have um, values in a column that appear frequently. So, like, in this column, there's three possibilities: M, F, and null. And there's, thousands of rows. So this is a really good use case for the categorical generator. It's going to look at the frequency with which each value occurs. Maybe M is 45%, F is 54%, and null is 1%, perhaps, something like that, right? And it's going to, when it de-identifies the column and writes it to the output database, it is actually going to preserve those probabilities. So, if M appears 45% in the source, it'll appear roughly 45% of the time in the output. So it'll preserve that, that statistical property of the column. I might want to do the same thing with marital status. This looks like categorical data to me. So what I've essentially done now is shuffled both those columns, but I'm shuffling them independently of each other, right? Let's say, for example, that in this data set, men are more likely to be widowed than women. I mean, I don't think that's actually true in the data set, but pretend it is. If I want to preserve that relationship, all I need to do is tell Tonic to link the columns together. When you link columns together in Tonic, it is actually going to know there's a relationship, and it'll go about preserving it, and it'll preserve it in the correct way. So now, instead of shuffling the columns independently of each other, I'm actually shuffling tuples of values, gender and marital status. So we'll preserve any, statistical properties that exist between the columns. I can go over here and do the same thing with occupation. We decided occupation wasn't sensitive. I could make it sensitive, or I could not. What I can do is apply a categorical generator as well. Like, presumably gender and marital status also have a strong, relationship to occupation. Like, they probably all inform each other. So let's now throw occupation into the linkage. Cool. When I do that, you can actually see what's going on here, right? There are 544 unique combinations of gender, marital status, and occupation, and we're going to be preserving the frequency counts of all of those combinations appropriately. Notice this little toggle right here. This enables differential privacy. So, we were talking earlier about, the uniqueness of lat long values, right? Like, when you have a bunch of lat longs clustered together, you don't have to noise them very much to preserve privacy. But if you have lat longs that are really far apart from other lat longs, you need to noise them a lot more. Well, the same is true for this categorical data, right? Um, if you have combinations of these values that occur very frequently, you can use those pretty safely because there's plausible deniability. But then you have, if you have, unique combinations that appear very infrequently, that might actually not be safe to sample into the output database. So we use differential privacy here to actually remove combinations of values that don't appear sufficiently frequently. And when you enable it, what it's actually going to do in this case is it's going to cull a lot of values. So we went from 544 unique combinations down to 7. It's only those 7 combinations that appear so frequently we can actually sample from them and have, some modicum of privacy. So let's keep that on. We have some numerical columns here: income and largest bill amount. If I wanted to do anything with those, I could use a continuous generator on annual income. That's going to look at the distribution of incomes, and it's going to create a new distribution that's similar to the original, but every value is going to be drawn from it at random. So every de-identified income is going to be, fairly independent of the original income, but the aggregate distribution is going to look the same. If I care about preserving the relationship between income and occupation, I'll just take care of it right here. And now we're going to generate appropriate incomes per fake occupation. So when we go to write that output database, we're going to choose an occupation at random. And then based off of that random occupation, we are going to sample from the correct income distribution. If I care at all about this numerical column, I can do the same. I'll make it continuous. Let's say we want to preserve the correlation between bill amount and income, right? Like, maybe as your income goes up, your largest bill goes up. If we care about that, well, let's link them together. It'll preserve that relationship as well. Going back over here, we have email. A lot of fun things we can do here. Simplest thing, do a character scramble. That is going to basically scramble the text but preserve the format of the text. And by that, I mean it's going to take every lowercase letter and map it to a random lowercase letter. It'll do the same with uppercase, and punctuation remains the same, and white space remains the same. So you end up with strings that look like the original strings, but they're nonsense. So you can see here, all the lowercase letters are scrambled. The punctuation, the at and the dot are preserved, and then you get more scrambling here. If I was, for example, to do that on this column here, look what you get. The hyphen is still there for non-member, and the E and the V remain capitalized because the N and the M were capitalized, right? Notice that it's random every time. But if I go back and turn on consistency, look what you get. So here's a non-member, non-member, non-member. This value is member, etc. Right? This might not work for all people, right? Sometimes you actually want to control the output email domain so you can programmatically verify emails are being sent. In that case, use the email generator. I'm going to use mailcapture.hasura.com. When I do that, it's going to create fake email addresses that all have that domain. So now if you guys actually own that domain, you can programmatically verify that emails are being sent in staging. Very good. For the sake of time, I'm actually not going to go through our date columns right now. I will comment though that a lot of our customers have JSON that they store in relational columns. It's super common. In fact, we use that ourselves in our own internal application database. If I want to de-identify JSON, you simply go add a JSON mask generator, and I can then click on the various values that I care about and apply any generator I like. And of course, I can do this as many times as I want. So, wherever there's sensitive data in the JSON, I can do this, and it'll apply this transformation in any JSON blob in the column that has an object called name with a value with a property called first. And I'm going to save it and not add anymore for now. But you'll notice that the name is now Leonida. Previously, it was Alexandra. If I go over here, it's also Leonida because previously it was Alexandra, and I have consistent name generators on both columns. So that is basically how you de-identify data in Tonic. Obviously we need to go through all of the other columns in the database that have been marked as sensitive, but this is a really quick way of beginning to de-identify your data to a really high degree of quality. That's why we call it, it's not bad fake data, it's good fake data. I'll quickly call out just a few other features in the product. I think actually I'll just call out one for the sake of time. We have a really great subsetting engine. It is really common for our customers to have terabytes of data in production and not really need all of that data in their staging or their dev environments. So our subsetting engine will actually take a database and reduce it in size by removing rows from it, but it will maintain referential integrity. So it actually traverses a massive dependency graph of your database represented by foreign keys and primary keys, and it will generate an output that is at the specified size but maintains referential integrity. A lot of our customers actually use this so they can get like local dev environments set up. So each developer can have their own development database that's only a few gigs in size. It'll be a really high quality, really representative few gigabytes of data, but it's manageable now, right? Like they can even like go put it in a Postgres Docker container and have developers just pull these Docker containers when they need application databases. It's a really really great and handy feature. Yeah, that's it. I think we get into there. I hope everyone, all of our viewers today, have gotten a sense of how you can de-identify and also subset your data.
That is, I mean, there's a lot of thought that has gone through this tool. That's really
absolutely
quite impressive. Yeah.
Thank you.
Yeah, let's go ahead and run that generator. I'll bring up my screen again so we can just have a look at it. And,
that's right. So I didn't include it, but I'll just kind of do it off screen. I didn't actually click generate data in the top right corner. So let me go do that.
So while that's running, I'm going to go ahead and just look through the data set we have here again one more time. So we've got our top 5. We've got a widowed psychologist. We've got a retired, just a retired person, 136,000. It's not a bad annual income for retired.
No, it's not. They must have good investments.
Seriously.
So
Cobbler,
the de-identified data is it is getting piped through now. So if you were to refresh if you were to refresh now, the customers table will be there.
So
it is copying over other tables though.
Let's see if Postgres remembers the table positionings. or not Postgres, but Hasura. And I think it should because of the metadata, but we'll have a look here. It's scanning the database. So it looks like it's remembered all the tracking locations. So now if we go back to that API Explorer, we run this query again here. What we should get is now de-anonymized data. We have an unexpected, so permission denied. Did the permissions need to be reset again on the database?
Um, the database was not dropped in any way, but I mean, I can definitely just run them again. Just give me a second.
Yeah.
All right, I've just run them.
Let's try that again. There we go.
Awesome.
So now we have so it looks like we did not randomize the occupations.
We did. We applied that
Oh,
categorical, that shuffling generator. They just look real.
It just happened to be the same one, because that is part of being random. Is you might get we got a psychologist twice in a row, but the person is different. The income is relatively similar. Yeah, I mean, that's all looking relatively new to me.
Great. And if we were to do if we were to get into more statistical analyses, if we were to be like, okay, well, how many unique occupations are there and what are their counts, or what's the average income for a retired person in the source and the output, we'll be able to preserve all of those relationships as well with the configuration that we provided to Tonic.
That is really impressive. I'm wondering if we have that ability. Let me just see if that query is easily determinable. I mean, we didn't have a before and after to compare it to.
I know.
The
Yeah.
customers aggregate on the average or annual income.
Yeah. But this will have to group by occupation.
Yeah.
If you want to look at it by occupation.
We don't have group by yet.
Okay. Sorry,
but that's fine. Yeah. So that, anyways, the value proposition there is really impressive. Are you able to generate new tables to the output so that you have original table and prefix?
No. The whole shtick of Tonic, the whole point is the output is identical to the input in every way: the structure, the schema, the foreign keys, indexes, primary keys. But the columns that have sensitive data have now been de-identified, and it's devoid of anything sensitive. But it will be identical in every other way, because the real motivation for the use case that I've gone over today is a valid application database that you can immediately plug into your dev and staging environments for testing.
And then if I wanted to, because in the case where my de-identified data is actually part of my product set, so I'm actually shipping to my BI team de-identified data, and I'm shipping to my application team the real data. I could then add both of these data sets as two different databases. One is my de-identified,
Certainly.
One is my original, and then to the permissions that our users are aware of. I'd be able to go in there and actually toggle which tables are visible and available to which roles, and
That's right.
and have that also still single API for both my developers and my production.
That's right. That's absolutely correct. And there's a lot of cool workflow features in Tonic for okay, well, I have one source database, but I have different teams that need outputs, and the outputs need to be a little bit different. So there's a lot of cool workflow features in Tonic for setting that up and having to avoid reconfiguring it a second time in a similar way, things like that. Yeah, so I think these products, I think, really clearly play really nicely together. This is awesome.
That's this is a really great a super powerful tool, and for anybody who's watching this, if you're working with data with Postgres, or any database, any of the data sets that you're supporting, that has so much value from personal use case as well, where I've had to in the past try to fuzz the data or say, okay, I'm trying to create fake data that resembles what I know is in my database, and that just is a mess. So tools like this are going to just save so much developer time. It's not even funny. This is really incredible. So super cool tool.
I love it.
Yeah. That probably actually wraps the demo. If somebody wanted to kind of get into this topic more, what else can they go into to read more about de-identifying data, learning a bit more about those trade-offs, so they can sort of also self-identify which columns might be identifiable for their specific data set? Yeah.
So it it depends a lot, right? Like a good starting point, I would say, is our blog at tonic.ai. And then, depending on what industry you're in, there's actually a lot you can read up on in various industries, right? Like the healthcare industry, for example, has the HIPAA guidelines and the HIPAA standards. There's actually a lot of good detail in those standards for like what's considered sensitive and what isn't. HIPAA is actually great in that way, where they very clearly define what's sensitive and what isn't, and actually kind of makes it easier for you. Um, for those that want to get a little more advanced in mathematical, check out differential privacy. Just go read the Wikipedia article and go from there. It's a great place to start. Really, really interesting field.
Very cool. Well, I really appreciate you taking the time today and showing us your tool. This is going to be, I think, a video that a lot of people will be able to reference. What's the fastest way to get started? Do you have a self-service tier, or is it all contact sales, or what's the fastest way to get started?
We are contact sales, so go to tonic.ai. You can get set up with a salesperson and a demo. I actually might be on the call to answer questions and to give a more detailed demo for those that are interested. And yeah, and then we go from there. It's a pretty painless process.
Very cool. Hey, thanks again for joining tonight. Really appreciate that. And we will say goodbye to our audience for today. We'll see you next week with even more great content, and have a great rest of your day.